Okay, so we figured out, or we've discussed, the concept of being able to utilize your calculator to work out the angle given you know the relationship between the two sides, opposite and hypotenuse. You could do cos to the power minus 1 and you will end up with a circumstance where you will need to type in the adjacent and the hypotenuse and it would tell you exactly 30, not 30 degrees, it tell you exactly what the degrees is that will come out. So for example, if it were 10 and 20 for cos theta, you can see here that a circumstance where you have 1 over 2, so it would be 10 over 20, or 1 over 2, notwithstanding that root 1 is equal to 1. So if you have a circumstance where you typed in 10 over 20, which is the same as 1 over 2 for cos theta, it will come out with 60 degrees instead on your calculator. But for us, because we've used sine, so it's opposite divided by hypotenuse, not adjacent divided by hypotenuse, we'd have 30 degrees come out on your calculator. Here, 30 degrees represents the size of the angle if there were a right angle triangle with a hypotenuse that was twice as big, e.g. 20 centimeters relative to 10 centimeters. And that there, as I'm just describing in detail what is occurring for this equation here. Note, for exam questions, you can have x instead of theta, so this comes out quite consistently. And I'm going to give you a specific question. I'm saying, can you consider the following? Can you consider sine x is equal to 0.799, and they wish for you to find out what x is. What is the angle? What is the angle when the relationship between opposite and hypotenuse, opposite divided by hypotenuse, equals 0.799? Notwithstanding, so that you recall that this is the same as opposite divided by hypotenuse, it's produced a value of 0.799. I want to know in this question what angle allows for that relationship to be equal to 0.799. Okay, so where 0.799 is the value of the opposite side's lengths divided by the length of the hypotenuse at a right angle triangle, how do we go about solving that one? And so the answer is, we write it in the calculator synonymously to what we did before. So then what we have is you write sine to the power minus 1, wherein as before with sine to the power minus 1 we had two sides, 10 for one, 20 for another. We've calculated this. If you wanted to calculate this, it would come out as 0.4 or 0.5 as a decimal. And so therefore it's the same thing that's occurred here. There is an adjacent divided by hypotenuse here. Hidden within this concept there is an adjacent, and it is being divided by an equivalent hypotenuse, and that division is the same as 0.799. So what degree should manifest from that? So if you do sine to the minus 1 0.799 and put it in your calculator using the shift button and sine, which can be typed into your calculator quite comfortably, you'll get around 53 degrees. And what I want us to do is to analyze what that looks like. We've discussed how the cos function looks something like this. That's the cos function. And that the sine function looks something like this. And we've discussed how it is related to right angle triangles within it. So what I want us to do is to now look at this graph rather than analyzing the right angle triangles or the way in which they fit into the circle to make such a graph, or circle-like structure, to make such a graph like this. What I want to do is I want to analyze how this graph can be useful in working out the angle and representing it so that it's visible to us in a different manner. So this is the graph, and we're going to be having a look at that in the next segment.